Hello and welcome to week 3 of the software engineering course. In the last week, week 2, you read about and studied about plan-driven software development and agile software development. You also touched waterfall model, the incremental development model, and the integration-based development model, and you completed a homework and a worksheet on the same. You also read about testing a little bit and coping with change and prototyping. This week, we're going to dig deep into agile software development. So before I start talking about this week, I would like to mention that this week is based on 2 chapters from the book. It's chapter number 3 and chapter number 4. Chapter number 3 is about agile software development, and chapter number 4 is about requirements engineering. So agile software development, you're going to talk about agile methods, development techniques, project management, scaling of agile methods. And so what agile methods really are rapid software development methods. And because they are rapid, they reduce the delivery. So if you're developing on a new project, a new product, if you're thinking about starting up a new business with a cool business idea, you are probably most likely going to use agile methods. So your time to market is drastically reduced. Agile methods help accommodate change better. The team, they work in smaller sprints, and those smaller sprints have well-defined goals that the teams accommodate. If there is some work that is left from a particular sprint, that obviously is carried over to following sprints. An important aspect of agile software development is that the focus is on software development and not so much on documentation. And there's a kind of a word in the industry which basically so seasoned software developers or software project managers basically think that a lot of the time is taken up by documentation, and agile software development basically does away with all of that. So there is still documentation, but documentation is not as extensive as other development methods. And time to market is an important factor. Don't forget, time to market is one of the best selling points for agile software development. It saves time and money, and you can have frequent software releases. This is how most startups tend to work. If you go to any startup, most likely they're going to they will be using agile software development. If you ask about documentation, most likely you'll not find a very formal document saying that this is the documentation. Most likely it's just word of mouth from one developer to another, and so on. This is a good thing because it saves time, but it also means that if a developer goes away, he or she takes away a lot of the knowledge about the software with them, and the incoming developer has to spend all that time, more time, to actually get comfortable with the code. Teams obviously keep hopping between, in agile software development, teams keep hopping between the requirement engineering phase and the design and implementation phase, and then going back to requirement engineering, then design and implementation. Then there is another important concept that you'll read about, and that is refactoring. Refactoring essentially means once you write code the way you want, and it may not be an optimized version of the code. So refactoring is visiting that code again to optimize it in any way possible. So reducing time, reducing complexity, reducing number of calls, or whatever, but making it better, making it perform better. One of the major development areas related to agile software development is Scrum. So Scrum is an agile method. It has a planning phase, it has a series of sprints, as I mentioned, and then you close the project. So you plan your sprints initially to start with, and then you divide those sprints into maybe 1 week sprint or 2 week sprints, typically 1 week sprints. In 1 week you have a set goal, you have to perform a certain number of tasks. Once that is done, you move on to the next sprint. So there's a meeting in between, and then you move on to the next sprint, and then you keep moving on to next sprints as you have planned. And once all the sprints are over, ideally your project would have been completed, and then you uh, uh, basically close the project, you deliver that project. Agile methods are basically, I should not say they are more suitable for smaller projects, but they are really suitable for smaller projects. But you can scale them well as well, and that's something that you're going to read about as well, how to scale agile methods. So that was for chapter 3. In chapter 4, you're going to read a lot about requirement engineering. How is a requirement how are requirements gathered from the user, and how are they formalized in a way with, uh, based on which a developer can actually develop something. So when a user says, I need a software that keeps track of the amount of medicine that I sell, that's a pretty high level requirement. Uh, but then again, a developer cannot work on this until you tell the developer that this is exactly what you want. So the developer has to actually convert that high level requirement into actionable items. So a requirement itself can be a high level statement to a detailed specification. So a requirement can be a very high level statement, or it can be a very detailed specification. Two types of requirements: a functional requirement and non-functional requirements. So a functional requirement is the thing that needs to be done, the service that the system needs to provide. A non-functional requirement is based on functional requirement, in that these are constraints in order to provide those services mentioned in the functional requirements. Non-functional requirements apply on the system as a whole rather than a component of the system. For instance, security. It affects the entire system. It affects how you develop each piece, each module. If your system has to be secure, each module is developed differently. And if security is not a concern, each module is obviously developed differently. And then there are domain requirements, which are basically because of a certain domain that your software falls in, the software that you're developing. So for instance, if you're developing a public video upload software like YouTube, you need to make sure that there is some way for you to check for pirated content or pirated audio and video. So that is a domain requirement that you must have, or other requirements related to the area. So you're going to read about engineering process, requirement elicitations, requirement specification, validation, and requirement change. So this is a handful for this week. So make sure you have enough time at hand to go through all the readings and videos, and I wish you a wonderful week. Thank you.